Hello and welcome to today's video. In this video I will be going over the topics of chain rule. In today's agenda I will be showing you the rule and then providing you with the proof, and I'll end it with a few examples. So first is the chain rule. The chain rule is a very simple but a very helpful rule. It helps us find the derivative of functions that have inner function. So let's say if we have y equals f at g of x. F is the outer function and g is the inner function. So right now, if you want to find the derivative, it's kind of messy. Let's just simplify it a bit. So let u equals g of x. Therefore, if we find the derivative of u, it'll be u prime, or equals du, same thing, g prime of x. Now let's sub it in, and we will get y sub u in for g of x, we'll get f at u. Now if we want the derivative of this, we just take y prime equals f prime at u. But this derivative is in terms of u, because we're taking dy over du, but we don't want that. That's what it is. We don't want it. We want it to be in terms of x here. So this is in terms of x, dx. And we want in terms of that. Therefore, we multiply this. If we multiply these two together, we get du over dx, and we can get rid of the du's, and therefore we will be left with dy over dx. Therefore, we have to multiply this by u prime, and if we sub back in these two values, we get f prime at g of x times g prime of x. So that's pretty much the chain rule. It's basically the derivative of the outer function evaluated to the evaluated to the inner function g of x, outer evaluated to g of x multiplied by the inner function. So the inner multiplied by the derivative of the inner function. Sorry. So time for the proof. So say if we have an example, h of x equals f g at g of x. So basically the definition is h prime of x would be the limit of h x plus h minus h of x minus all over h. So next we just sub in the h of x, the functions in, and we get this. After that we just multiply by g of x minus g of x, g of x plus h minus g of x, all over the same thing, and that's equal to 1, and we can do that. After that, if we just rearrange it, if we bring this the denominator to this side and h to the other side, we get this: f at g of x plus h minus f at g of x all over g of x plus h minus g of x, and to the limit as h approaches 0, g of x plus h minus g of x all over h. So this basically looks like that, but with g's. Therefore this is g prime of x. In this case, this is kind of messy, so let's let g of x plus h minus g of x equals k. So we can replace this denominator with the k, and we can rearrange this, and we'll get k plus g of x equals g of x plus h. Therefore we can replace g of x plus h with k plus g of x. So if we do that, we get, and so basically next we just sub them in, and we'll get a limit as k approaches 0, f at g of x plus h, no, g of x, yeah, plus h, oh no, sorry, that's a k, plus k minus f at g of x all over k times, we already have that, g prime of x. So this pretty much looks like that again, except for instead of x we have g of x, and instead of h we have k. Therefore this is pretty much f prime at g of x times g prime of x. So here's the proof. Next is the examples. So say if we have h of x equals fx squared plus 7 all over to the power of 7. So this is kind of messy. Again, like make it easier by saying u equals fx squared plus 7. And let's just get the derivative of this, and that'll be u prime equals 10x. Next is sub the values in. H of x equals u to the power 7. Now it's much easier. the derivative of this is 7 comes out of the front and the power decreases by 1 times u prime, because it's a chain rule. We have to do that. Therefore, we have u prime here and we have u here. So if we just sub it in, we'll get fx x squared plus 7 to the power of 6 times 10x. So the second example, I should put 2 here, would be is h of x equals sine and x squared all over to the power of 2. In this we have two, we have an inner function that has an inner function. So let's start from the most inner function, and that's x squared. So let's have v equals x squared. Therefore v prime equals 2x. And our second most inner function is sine x squared. So let's say u equals sine. Instead of putting x squared, let's put v, because we're subbing it in here. And u prime would be cos v times v prime. And now let's just put it in again. So it'll be h of x equals sine x squared is sine v. It's u. So it'll be u squared, and this is kind of simple. We know this. And the derivative of this would be h prime of x equals 2 comes out of the front, and the power decreases by 1. Next, we just sub it in, times u prime, sorry. Next, we just sub it in. We know u, that's 2 sine v times cos v to the power of times v prime. Now, we're still not done yet. We can put we can put sub now the v's in. And if we sub it in, we get 2 sine x squared cos x squared times 2x. And here's pretty much what happened, like, if you want to do it. So let's say that h of x equals y. It'll be dy over dx. So first we did was put it in terms of u, so it'll be dy over du here, and then we multiplied du over dv, and then we did dv, this thing, dv times dx. As you can see, the du's cancel out, dv's cancel out, and we are left with dy over dx. So here are examples you can try for yourself. Pause the video, and I'm going to show you the answer now. So here are the answers. For the first one, it's secant x squared times 2x plus 7. And I'm just showing you that I'm taking the derivative here, u prime. And same with here, I'm taking the derivative separately. And that's the second one. And for the third one, I didn't show that, I just did it in one step.